When the first images of 3I Atlas appeared, astronomers thought it was just another faint blur lost among the stars, a ghost passing silently through the solar system. But then its trajectory didn't make sense. It wasn't orbiting the sun. It was escaping it. And its velocity, nearly 60 kilometers per second, whispered one impossible truth. This object was not from here. For the third time in recorded history, something from another star system had entered ours. First came Oumuamua, then Borisov, and now 3I Atlas, a celestial trespasser with an origin no one could trace, a composition no one could match, and a mystery that might rewrite everything we know about interstellar matter. Unlike its predecessors, though, this one isn't just flying by too fast to catch. For the first time, its path may actually allow us to reach it, to touch it, to hold, in human hands, a fragment born under an alien sun. Scientists around the world are already sketching blueprints for a chase. NASA's Comet Interceptor, ESA's early mission concepts, private initiatives whispering of a probe that could leave Earth before the decade ends. The goal is simple and staggering: intercept 3I Atlas before it disappears forever beyond the outer planets. But there's a deeper question under the math and the engines. What does it mean to touch something that was never meant to be touched? Because if we succeed, we won't just be reaching a rock from another world. We'll be touching a message written across light years, and the question that keeps echoing through every control room is, what will it say back? To understand what makes 3I Atlas so extraordinary, we have to retrace the instant it was first spotted. April 2024. The Asteroid Terrestrial Impact Last Alert System, ATLAS, detected a dim, fast-moving object gliding through the constellation of Serpens. At first, its orbit was cataloged like any other comet, but within days, astronomers noticed something odd. Its eccentricity wasn't just large, it was greater than one. That number alone meant everything. It proved that 3I Atlas wasn't gravitationally bound to the sun. It was on a hyperbolic trajectory, arriving from deep interstellar space and destined to leave it again. Its speed at perihelion exceeded 58 km/s. Its approach angle didn't match any known solar system plane. And spectroscopy hinted at volatile compounds never observed in our local comets. Cyanides, carbon chains, and dust signatures hinting at a completely alien chemistry. Yet, unlike Oumuamua, which slipped past before anyone could even prepare a mission, or Borisov, which fragmented too fast, 3I Atlas moves slowly enough and predictably enough that we might actually have a window. ESA's Comet Interceptor, originally designed for a yet unknown target, might just be our ticket. Scheduled for launch near the end of the decade, it will wait in a gravitational parking spot at L2, ready to sprint toward any newly discovered interstellar object. For the first time, humanity has a probe built specifically to chase visitors from beyond. But reaching 3I Atlas isn't like catching a comet. Every maneuver demands exquisite timing, a ballet of velocity and light years. To intercept, the spacecraft must exit Earth's orbit, match a fragment of the object's velocity, and cross millions of kilometers in near-perfect alignment. A feat requiring energy levels at the limit of our current propulsion. New mission concepts are emerging. NASA's Interstellar Probe program has studied solar sails that could accelerate using sunlight pressure alone. Others imagine nuclear electric engines, capable of steady acceleration over years, slow but unstoppable. Private groups inspired by the success of Breakthrough Starshot are even experimenting with laser-boosted microsails that could catch the object's trail before it vanishes into the outer dark. What makes the challenge poetic is this: 3I Atlas won't wait. Every second it drifts further away, its orbit stretching like a promise we might never fulfill. But the dream persists: to reach it, sample it, and decode its secrets. Because in that dust could lie the chemical recipe of another solar system, or even the signature of prebiotic molecules that once drifted between the stars. It's not just a chase against time. It's a race to understand how many worlds like ours exist, and whether life's ingredients are scattered everywhere, waiting for someone to catch them. And as teams refine their trajectories, one eerie detail remains unsolved. 3I Atlas doesn't reflect light the way it should. Something about its surface breaks the rules of what we thought interstellar ice should look like. For centuries, we assumed we understood what a comet was, a dirty snowball of ice and dust, predictable, solar-born, sculpted by the same cosmic forces that built our planets. But 3I Atlas is quietly dismantling that certainty. Its reflectivity is strangely muted. as if its surface swallows sunlight instead of scattering it. It's coma, the glowing halo of gas that normally forms when a comet nears a star, flickers unevenly, then disappears entirely. For a while, it looked as though it had stopped reacting to the sun. Some observers even suggested that its material might not be ice at all, but something darker, tougher, perhaps carbonized silicates forged under alien stellar winds. If that's true, then our old categories, asteroid, comet, rock, ice, start to blur. 3I Atlas could be a hybrid from a planetary system that evolved under conditions completely unlike ours, maybe around a red dwarf where volatile compounds behave in ways we've never seen. The illusion we've lived under is simple, that our solar system is the template for others. Every new discovery, exoplanets, rogue worlds, cosmic debris, was quietly bent to fit our local logic. But when we observe something like 3I Atlas, the universe stops agreeing with our definitions. It refuses to look familiar. In a lab at the University of Hawaii, a team is running simulations of what its surface might be made of. They feed spectral data into chemical models, expecting to reproduce its color signature. None match. The material seems to absorb across wavelengths that should be impossible for natural compounds in interstellar vacuum. The data hint at a layer of organic polymer, maybe the residue of cosmic radiation on ancient ices, maybe something more exotic, more synthetic. If 3I Atlas is truly covered in a crust that resists sublimation, then it's not behaving as nature would dictate. It's behaving as though it was hardened, protected, for a journey through interstellar space. And that's when the illusion breaks completely. Maybe comets aren't fragile relics at all, but survivors. Maybe the interstellar medium isn't just dust and emptiness, but a crucible that transforms them into something enduring. Cosmic messengers wrapped in armor. If we ever reach 3I Atlas, we won't just be touching alien matter. We might be touching a survivor of deep time, a witness from a system that no longer exists. And the more we decode its silence, the more it feels as if it carries a story it's been holding for billions of years, waiting for someone to finally listen. Every revelation about 3I Atlas has come not from direct contact, but from light, thin, delicate threads of data stretched across the void. Each new observation has acted as a rung on a ladder, leading us upward through layers of understanding and uncertainty. First rung, observation. The initial photometric data showed erratic brightness variations, pulses that couldn't be explained by simple rotation. This told astronomers that its surface was irregular, perhaps fractured, spinning chaotically, much like Oumuamua. But when its spectrum was analyzed, it displayed an unusual dominance of carbon-based absorption lines, a sign of rich organics. These readings place 3I Atlas among the darkest objects ever seen, reflecting less than 4% of incident sunlight. Second rung, pattern. As more telescopes joined the watch, from Mauna Kea to the Very Large Telescope in Chile, a subtle pattern emerged. The gas emissions didn't align with its sunlit side. Instead, they seemed to erupt from specific regions, almost like jets firing intermittently, adjusting its motion. This hinted at compositional variation, pockets of volatile material buried beneath an insulating crust. That crust, some models suggest, may have formed after millions of years drifting through cosmic radiation, which restructured its surface chemistry into something close to tar. Third rung, hypothesis. If that's true, then 3I Atlas isn't just a frozen relic, it's a chemical time capsule. Its molecular complexity could preserve the prehistory of another planetary system, one that formed around a different kind of star, maybe richer in carbon, poorer in oxygen. Its isotopic ratios could tell us whether water and organic molecules are universal outcomes of stellar evolution or rare coincidences of our own neighborhood. Fourth rung, implication. Should we manage to capture even a microgram of its dust, it could reveal whether interstellar comets act as delivery systems for life's ingredients across the galaxy. That idea, panspermia, has hovered at the edges of science for decades. But 3I Atlas offers something unprecedented, a natural experiment. A probe equipped with a dust collector could test, at last, whether biology's building blocks truly migrate between stars. Every rung of this ladder pushes the same conclusion. 3I Atlas isn't random. It's part of a cosmic network of exchange. Material, chemistry, maybe even memory, linking distant systems across light years. And yet, one final measurement still refuses to fit the pattern. The object's trajectory has a slight, persistent deviation. It moves as though something beyond solar gravity and known jets is nudging it off course, by just enough to be noticed, but too little to explain. No one agrees on the cause, but whatever is guiding it doesn't seem entirely natural. There's a quiet moment in every discovery when data turns into doubt, when the numbers start whispering something that feels less like science and more like philosophy. 3I Atlas has brought us to that edge, because if this object truly comes from another star, carrying organic compounds shaped by alien chemistry, then we're forced to ask, what is an origin? Is life's birthplace a single planet, or the galaxy itself? The non-gravitational acceleration that slightly alters 3I Atlas's trajectory echoes the same mystery that haunted Oumuamua years ago. Back then, we argued over explanations, sublimation, gas jets, even radiation pressure. But beneath those debates, something larger stirred. An unease with the possibility that interstellar objects might not all be inert, that some could be engineered. Most scientists resist that idea, and rightly so. The universe doesn't need intelligence to create wonder. Radiation, chemistry, and time can sculpt miracles. Yet the data's precision, its defiance of every known model, lures the imagination into dangerous territory. Could these objects be the driftwood of civilizations long extinct? Could their surfaces, hardened, smooth, strangely geometric, be more than coincidence? Maybe the real shock isn't whether 3I Atlas is artificial or natural, but that the line between those two words has blurred. Humanity too is now sending emissaries into interstellar space. Voyager, Pioneer, New Horizons. To another species, thousands of light years away, our fragments might look exactly like 3I Atlas looks to us, cold, silent, and inexplicably deliberate. So what if this is the universal pattern? Civilizations rise, send messages of matter instead of words, and vanish, leaving behind silent travelers that bridge time and meaning. 3I Atlas could be one of those messages, not a beacon of light, but of endurance. It reminds us that space isn't just emptiness between stars, it's a medium of exchange. Every rock, every grain of dust is a courier of memory. And when we speak of touching 3I Atlas, maybe what we're really longing to touch is proof that we're not isolated, that life, intelligence, and curiosity are not local accidents but cosmic habits. In that sense, 3I Atlas isn't just an object, it's a mirror, reflecting the question that has always haunted our species. If the universe is filled with travelers like this, are we one of them too? And just when that thought begins to settle, another emerges, quieter and more unsettling. What if 3I Atlas isn't coming from somewhere, but returning? The race to reach 3I Atlas has already begun, not on launch pads yet, but in blueprints, simulations, and whispered collaborations between agencies that rarely share their dreams. Because if we can intercept it, even for a moment, humanity will cross a threshold we've never reached before. Our first direct contact with interstellar matter. ESA's Comet Interceptor stands at the front line. When launched, it will wait near the L2 point, like a sentinel poised for a signal. The moment a new object's path is confirmed, it will detach, ignite, and sprint toward it. For 3I Atlas, engineers are recalculating every variable: the burn windows, the energy cost, the instrument payloads. It would need a multi-stage intercept, one probe for high-speed imaging, another for dust capture, and a third for particle analysis before the object races away forever. New propulsion concepts, once theoretical, are becoming crucial. Solar sails, thin as thought, driven by light itself, could be unfurled toward the object's wake. Ion engines might maintain a constant acceleration for years, reaching velocities that chemical rockets could never dream of. And nuclear electric systems, long confined to paper studies, are finally being reconsidered. But the challenge isn't just technical, it's temporal. 3I Atlas is already leaving. The deeper it travels into the outer solar system, the fainter it becomes, until the photons it reflects are barely measurable. That's why some scientists argue for a bolder step, a pre-deployed interstellar rapid response mission, stationed far from Earth, ready to chase the next visitor before it even arrives. This new paradigm, of readiness rather than reaction, could redefine space exploration. It's no longer about waiting for discoveries, it's about intercepting them as they happen. A living, adaptive science fleet, permanently stationed in the frontier between planets and stars. The consequences reach further than any one mission. If we succeed in touching 3I Atlas, it could catalyze a new era of cosmic material exchange, real samples from other systems, tested in our labs, fueling our understanding of planetary formation, chemistry, and maybe even biology. And beyond the data, there's the symbolism. A probe launched by a species that once thought itself confined to one world, reaching out to grasp the relic of another. It's the oldest human instinct to reach beyond the horizon. Only this time, the horizon isn't an ocean or a continent. It's the interstellar abyss. And in the distance, somewhere ahead of our technology and our imagination, 3I Atlas keeps moving, as if leading us towards something greater that waits just beyond the known sky. There's something profoundly human about the idea of touching 3I Atlas. It's not just about data, propulsion, or material science. It's about contact, the desire to reach out and feel what has never been felt before. For thousands of years, we've looked up and imagined stories written in the stars. But this time, the story isn't distant. It's passing through our neighborhood, silent and real, and for once we have the tools to reach back. Every scientist who stares at 3I Atlas's trajectory feels a quiet pull, the same kind that guided sailors beyond known maps. They're not chasing fame or even certainty, they're chasing connection. A connection to something older than the Earth itself, something that has been traveling longer than humanity has existed. To touch it, even for a moment, would collapse the unimaginable distance between out there and here. It would mean that the human hand, born on a small planet around an average star, has finally brushed against the dust of another sun. Maybe that's what drives us deeper into the void. Not conquest, not curiosity alone, but a kind of cosmic empathy. The realization that the universe is not foreign, it's family. Every molecule, every atom of us, was once part of a star that died so that others could be born. 3I Atlas is proof of that endless cycle. A traveler made of the same cosmic ingredients, shaped by a different story. Somewhere in its carbon veins might lie the same chemistry that once sparked life here. If that's true, then when our probe touches it, we'll be touching our own beginnings, mirrored, refracted through the light of another world. And maybe that's why this chase matters so much. Because beyond the equations and orbits, this is a human story about reaching, learning, belonging. Every mission, every risk, every hour spent calculating an impossible intercept is an act of faith that the universe is worth knowing. When the probe's robotic arm extends, when it brushes the alien surface and sends back the first particle sample, it won't just be a scientific achievement. It will be a moment of communion, a handshake across light years. And perhaps in that silence, the cosmos will answer in its own way, not with words, but with the quiet echo of recognition. You finally found me. When 3I Atlas finally fades into the dark, it will leave behind more than a trail of data. It will leave a silence filled with questions. Did we manage to touch it? Did we learn anything? Or did we simply witness a messenger passing by, reminding us of how small we are and how far we're willing to reach? Maybe we'll never catch it. Maybe its dust will slip through our fingers, untouchable as a dream. But perhaps that's the point. Every pursuit we've ever made, and the moon, Mars, the stars, has been less about arrival and more about transformation. Each mission rewires what it means to be human. If we do manage to touch 3I Atlas, even for a heartbeat in cosmic time, it won't just be a scientific milestone, it will be proof that we're capable of meeting the unknown, not with fear, but with reverence. That curiosity, when pursued deeply enough, becomes a form of love, the love of existence itself. And maybe, in some distant future, another civilization will find our relics drifting through their skies, wondering who sent them, wondering if they were ever meant to be touched. Because in the end, the universe keeps extending its hand. The question is whether we have the courage and the patience to reach back. So tell me, do you believe humanity will ever truly touch something born beyond the stars? Or are we still learning what touch means in a universe that never stands still?